All right, for your final exam review, question number 11. How can the graph of f of x equals 1/2 x plus 2 squared minus 5 be obtained from this parent function y equals x squared? All right, so the number in front, since it's 1/2, that's going to be a vertical. If it's outside, it's a vertical change. If it's inside the parentheses and multiplied by the x, that'd be a horizontal change. Vertical shrink by a factor of 1/2. And then this plus 2 inside the parentheses indicates that you would move this left 2 units, and the minus 5 out here would be down 5. I would, if I were you, I'd go to the page in your book that has all of the transformations so that you can study them and learn the differences between those. You can probably look up transformations in the index, and that'd be a good place to start. All right, question number 12. How can this graph be obtained from y equals 1 over x? All right, the plus 8 in the denominator is kind of like, it's like it was in parentheses. It's the grouping symbol. Here the grouping symbol is not parentheses, it's a fraction bar. So again, that would be left 8 units, and the minus 6 would be down 6 units. Down 6 units. All right, so that's how it's changed from 1 over x. Question number 13. And let me go back to these two. If you're not sure, what you can do is put the original one in y1, put the new one in y2, and then look at how it shifts and compare them that way. It's a little bit harder to tell that way, but it would at least validate your answer. And if you moved it, if you said left and it went in a different direction, then you'd know that something was wrong. All right, solve this equation. It's a quadratic equation, and we spent a whole chapter solving quadratic equations. The very first thing I need to do is move this 17 over to the other side. So 36 minus 17 would be 19, and set it equal to 0. All right, then I want to see, are there any factors of 19 that'll add up to 12? And now I can't think of anything because 19 is a prime number, so the only thing that will go into it is 1 and 19. So since that's the case, I could, I think I'll do this one by completing the square. If you would rather use the quadratic formula, you're welcome to do that. The next problem says use quadratic formula, so I'm going to save that for quadratic formula for the next one. So to complete the square, you would subtract 19, move to the other side, then you take half of this term, so I'd take half of 12, which is 6, and square it and add it to both sides. So I'm going to add 36 to both sides, which I guess is what they started with. I wasn't paying very good attention. So this side's a perfect square, x plus 6 squared. If I factored it, it'd be x plus 6 times x plus 6. That gives me x squared plus 12x plus 36. And on this side, I get 17. So now I take the square root of both sides, remembering that there's a positive and a negative. So on this side, I just get x plus 6. On this side, I get plus and minus the square root of 17. And then I subtract 6. So negative 6 plus and minus the square root of 17 would be my answer. The next problem says use the quadratic formula to solve it. So for this particular equation, since it's already set equal to 0, a is equal to 1, b is negative 10, and c is 34. So it would be x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so I'm going to need to use the calculator to do this part underneath the radical, I believe. Okay, so when I simplify this, I get x equals 10 plus or minus what's underneath here. When I do that, negative 10 squared is 100, and then subtract 4 times 34, you get negative 36 under the square root over 2. So that would be 10 plus or minus 6i over 2, because the square root of negative 36 is 6i. Divide everything by 2, your answer would be 5 plus or minus 3i. And that's my answer using the quadratic formula. All right, 15. The length of a rectangle is 3 inches more than the width. The area is 304 inches. Find the width of the rectangle. So I'm going to let the length be x plus 3 and the width be x. So the area is length times width. And they tell me the area equals 304. So now I just have to solve this. X squared plus 3x, that's what I get by multiplying x times x and x times 3. I'm going to subtract 304 equals 0. And then what I'm going to do is try to find factors maybe that can factor. Let me see. Um, all right, if I check all the factors of 304 and I just started with some and I tried some larger numbers and I found 16 and 19. And what will happen is they have a difference of 3, which is that middle term. Now, if you have trouble with factoring, you're always welcome to use the quadratic formula to solve this. But when I factor it, I could get it be, I need two numbers that'll multiply to give me negative 304 and add together to give me a positive 3. So it's going to be plus 19 and minus 16, set equal to 0. So I get x equals negative 19 and x equals 16. Well, it can't be negative 19 because we're talking about the width of a rectangle, which can't be a negative number. So the width is going to be x, so the width is going to be 16, and the length is going to be x plus 3, so the length would be 19, and the area of that would be 304. And they want to know what is the width. So the width is 16, is it inches? 16 inches. And be careful because x is 16, but sometimes they'll be asking for the length. So you want to make sure you're answering the question that's asked. Number 16, your company uses the quadratic model negative 11x squared plus 350x to represent how many units of a new product will be sold x weeks after its release. How many units can you expect to sell in week 12? So x is the weeks, so all you're doing is plugging in 12 where you had an x and figuring out your answer. Negative 11 times 12 squared. Negative 11 times 12 squared. So 350 times x plus 350 times 12 is 2616. That's how many units you can expect to sell. That's the answer. Number 17. Just a linear equation that we're going to solve, so we've got to distribute. 2 times x plus 5 will be 2x plus 10. 5 minus 4 times x is minus 4x, and minus 4 times 5 is minus 20. So we will combine like terms, add 4x, so on this side we get 6x, plus 10 equals, this will be negative 15. Subtract 10, I get negative 25, and divide by 6, I get negative 25 over 6. And that'd be my answer for x. 18, find the zeros using a graphing calculator. So y equals x squared minus 6x. Was it minus 5? Minus 5. And I'm going to, if I graphed it now, it's going to be, I have the window set up differently from an earlier problem. And it's fine, I can still see the zeros. If you want a standard window that's zoom 6, you can do that as well. I need these two zeros. I need to find out where it crosses here and over here. So second trace, I want a 0. I'm going to get a left bound, enter, and a right bound, enter, and then my answer is negative. Where do they want me to round it to? 3 decimal places. Negative 0.742 would be one answer. Negative 0.742, and the other one would be second trace 2 over here. I need a left bound and a right bound. Should be getting close. So this can be a left bound onto the left of that point. Then I need to move to the right of that point. And I get 6.742 if I round it correctly. So those are my zeros of this function. Number 19. Find the domain. For this particular problem, the domain is going to be all real numbers, or negative infinity to positive infinity. The way that I know that is there are no denominators. There's not a denominator. X cannot be a value that would make it divided by 0, but I don't have to worry about dividing. There's no dividing. I also can't have a negative underneath an even root, like a square root or fourth root, and there's not one here. So this domain is all real numbers. Number 20, my domain is limited. I do have a denominator, and what's in the bottom can't be 0, so x cannot be 3. So either I would write x cannot be 3, or if this is multiple choice, they may have it in interval notation. And if they did that, we would say our domain is from negative infinity to 3, but I put a parentheses, meaning it can't touch 3. And then it's from 3 to infinity. So it's everything except for the number 3. And we're going to stop right there, and I'll start a new video with number 21.